Okay, 2.8 problem 11 is a tricky one here. We're supposed to use, with the intermediate value theorem here, we're supposed to prove that for all positive integers k, the equation cosine of x is equal to x to the k has a solution. Okay, so that's what we're going for right here. So this is the way, this one works the way most of our intermediate value theorem problems work. We start off with an equation, and then our next job is to bring one term to the other side so that we get something that's equal to 0. So I'm going to leave the left side where it is. I'm going to subtract the x to the k here, and that is now going to equal 0. I'm curious. Now, does this equation have a solution? So I'm going to go ahead and call that function f of x. But I got to remind everybody, x is the variable here. K is not a variable. If I go back and read the problem again, k has to be a positive integer. So something like 1 or 2 or 3 or 37, but it can't be 0. It can't be a negative number like -2. It can't be a fraction or a decimal. So what I think I'm going to do then is try to make a table here of values, x and f of x, and see if I can come up with two integers right here, or two values of x, between which there's a sign change in this second column. So it doesn't say that x has to be a positive integer, so I'm going to go ahead and start with 0 here, and let's see what happens. We're now taking the cosine of 0, which is 1, minus 0 raised to any positive integer power is still going to be 0. So I start off now with a y value of 1. Okay, I didn't find the solution I was looking for yet. I wasn't really planning on it. Let's see what happens when we let x equal 1. Now, right away, I think you can realize we just ran out of luck here, guys. You can't take the cosine of 1 radian by hand. Okay, it's close to 1 is roughly pi over 3, and the cosine of pi over 3 is about 1/2, but I think this is actually, what, a little bit less than that? Anyway, we're going to need a calculator here to do this. So I'm on my iPad that has the Inspire app. Let's see if we can make this work out. So I'm going to go ahead now and define the function right here. I'm going to call this f1 of x. Here we go. And we're going to let that equal, and then I think I can go back to this page here. Okay, guys, it was going to be the cosine of our angle, which is x, and then minus then x raised to a power. And this is where I'm actually curious here, guys, how your calculator would handle this or not. I'm going to go ahead and do what I think a lot of you guys were going to do. I'm going to let k just equal a random positive integer. 2 seems like a good number to me. So I'm going to go ahead and put in an x squared right there. Now, even if I get this to work out, that doesn't prove right now that it works for all values of k. It just proves that it works for 2. But I think maybe I can extrapolate my idea. Let's see what we've got here, guys. So we already did. Let's just make sure we've got this right. Ooh, there's a way to get to an f right here, guys. Is it? Nope, not there. Not there. No. No, I looked this up before. There's the f I was looking for. Okay, so here we go. So f1 of 0, we went ahead and evaluated, and yep, we got that right. That was equal to 1. Great. But now the question was, what is the value of, here we go, f1 of 1? And I'm going to go ahead and, guys, on your calculator, you'd probably hit Control-Enter here. This is approximately negative, let's see, rounding that to 3 decimal places, it's a 0.459, but then a 6, so negative 0.460. Let me write that one down here, guys. So that equals negative 0.460. Did I get that right? Let me double check that. Negative 0.460. Got it. Now, right there, that did what I needed it to do. I went from a positive y value here to a negative y value. So, should have left myself a little bit more room here, sorry. There is no way here, guys, that a function that is continuous can jump from a positive 1 to a negative value without equaling 0, some in between, at some c value that's in between 0 and 1. So it happened here when k was equal to 2. Now I'm curious, let's see what happens if we let k equal 3. So I'm just going to go up a few times. There we go. Was that 5? I think I'm going to hit enter. And instead of that 2 at the end, I'm just going to delete that and put, no, that didn't work. And here we go. Put a power of 3 in there. Okay, got it. And now let me redo f1 of 0. I'm not sure it's going to be located in the same spot, but let me redo f1 of 0, that still was equal to 1. And now I'm going to redo f1 of 1. Right there it is, enter. And again, I'm going to hit control enter here to get that. And there you'll notice I got another decimal answer. And in fact, it ended up being the exact same decimal right there when we put in 1. I bet that wouldn't happen if I had used 2, but I think maybe that's the key to this problem here, guys. There's always going to be a solution between 0 and 1 as I'm looking at it and talking this out now, because regardless of the value of k, that could be 1, 2, 5, 37, whatever, 0 raised to whatever that power is always going to get you 0, so you're always going to get 1 here for this value. And then if you put in a 1 for x, it doesn't matter what the value of k is. 1 to any positive integer power is always going to equal the same value, and that's going to be 1 as well. So I was curious, let's take a look here, guys. What happens if I had redefined this function, and I believe that your calculator, the Inspire CAS, would let you get away with this. Instead of putting a 3 there, putting a random arbitrary constant of a lowercase k. So let me go ahead and hit enter. There we go. And now I'm curious, guys. Let's see if this works out. I think it's going to. If I put in f1 of 0, I think that we are still going to get the same 1 that we got before. 1 minus 0 to the k power. So what's the calculator doing? I think your calculator is saying it doesn't know what k is. We would have to reason then that since k is a positive integer, 0 to that power is 0, and that answer is just 1. And now, if we were to do f1 of 1, I think it's going to tell us something similar right there. Cosine of 1 minus 1. Now that one didn't depend upon the value of k, but that one, let's see, cosine of 1 is going to be less than 1. Therefore, subtracting 1 from that is going to end up giving you the negative result that we were looking for. So, yeah, it doesn't really matter what the value of k is. When you put in a 0, you're always going to get a positive result. And when you put in 1, you're always going to get a negative result. And that's why we know that there's a spot in between 0 and 1 where this equation here is always going to have a solution.